to my channel. In this video we're going to implement linked lists using Python, and we're going to be doing it with the singly linked list. Now in the previous video in this series I explained and visualized exactly how this linked list work. So if you haven't seen that video, you can just click on the top right side of your screen to watch that before coming back to this. Now let's dive deep into linked list and implement first the node. So the node is an object that has two values, which is the data and the next field, or the reference field. So in order to implement the node in Python, what we do is use the class object. So let's say class node, and let's define the initializer method. So let's say init and self. So we're going to be passing in the data we want to store in the node whenever we are creating it. So that's why we have the data here. Data can be of any type, of course. So let's say self dot data equals data and self dot next equals none. So we are saying self dot next equals none because right now when we are creating a node, we don't exactly know what comes next. So we are setting it to a non value. So that's why we have that. And yeah, let's go ahead and say, now that we have the node, let's actually see if the way it works. So basically, let's say my node equals node, and let's pass in some value. Let's say 7, and I want to print my node dot data. Right, so when I say python 3 main.py, now we have 7, and I change this to John, we have John. Right, so that works. Now let's go back and actually implement our linked list. So let's create a new class. Let's create a linked list class. So let's say linked list, and to initialize our linked list, we are doing something very simple. We are simply creating the head value, and because there's currently no item in our linked list at the start, that value will be none, or be a null value or non-value. So let's go ahead and say define init and self. Right, so now we can say here we want self dot head equals none, and that's basically all for the initializer. Right, so now let's write some methods to actually add values or manipulate or work with our linked list. So let's add first the append value, which is to add elements to the end of our linked list, or in the case where it's an empty linked list, we're adding to the start, of course, because the start is also the end in that case. So let's define an append method. Now in this case, of course, the self is like something we have to add to every method in Python's classes. So we're going to add also the value that we want to add to the end of the linked list. So here we'll put the value, and let's say, right, so the first thing we want to do now that we have the value that we want to add is to create a new node that we can now append to the list. So let's say new node equals node and value. So now we are reusing the node class in this case. Now we are creating a new node. So after this, now we have a new node, and now we have the address that we can use to add to our linked list. So first we want to check, is this linked list empty? If it is, that means that we are simply adding the current new node to the head of the linked list, because that's going to be the first item. So let's check if not self dot head. That means if our linked list is empty, we want to say self dot head equals new node, and here we want to return at this section, because we don't want to continue the code anymore. So now we have appended to the linked list, because what we did here is just we check if it's empty. If the list is empty, we append to the start of the list. So that's basically all. Now what happens when there are already items in the list? Let's say there's already one item. Now we want to travel, or let's say if there are 5 items, we need to travel, or as it is called, traverse to the end of the linked list before we can now add the item at the end of the linked list. So let me just go ahead and add a comment here, a few comments. top actually. So let's say create a new node, and here we are simply checking if the linked list is empty to add to the head instead. Right. So let's go ahead and implement the next. So what we want to do here is traverse to the end. I hope I spelled that correctly. To the end of the linked list. Right. So to do that, what we do is we use the while loop in Python. So let's say while, or before that actually, let's initialize the current variable. So let's say current equals self dot head. So this current is going to be our iterator. It's going to be the one we use to traverse over the nodes inside of our linked list. So let's go ahead and do this. So let's say while current dot next. Right. So this while loop is saying while we still have a next value. So let's just continue to run the items, the components of this loop. So now what we want to do is we want to say current equals current dot next. So what we are doing now is let's say we are at the beginning of the loop or the iteration, we are at the end of the linked list. Now I'm checking, is there a next value, which means do I have another item in this list? If yes, then let's proceed to that item. So we are switching the current to the next item, and this continues over and over and over again until we arrive at the end of the linked list. Now, when we do that, at the end of this loop, it will mean that our current variable would now contain would now contain the last item of our list. To actually confirm this, let's try to practicalize something, and let's say print current, right? But here I also want to print something that says appending to start of list, and here I want to say appending to end of list. Right, now let's go ahead and try to call this method a few times on a new list. So let's say my names equals linked list. So that creates a new instance of the linked list class, and now I can say my names dot append say Opeoluwa, and also I want to call it one more time. Say my names dot append right Jeremiah. Right. Okay, now what I want to do is I want to run this, and here you can see appending to the start of list, appending to the end of list. So on the first instance, on the first time we call the method, we append to the start of the list. The second time, we append to the end of the list. So here what I want to do is, as you can see right now, it's printing main node object, and this is the address of that node in my memory. So now, whenever we create a node and we get it, we just print the node itself, we can see this value, and this is the address. So now what we want to do here is to say, I want to print the data actually, not just the address. So when I print that, now we can see the last item here is Opeoluwa. Now let's do something. Let's say current the next equals new node. Right. So let me go over that one more time. So what happened here is we appended this value to the start of our list, right? And now we are trying to append this value to the end of our list. Now we have not appended it yet, but now what happens is this loop enables us to travel all the way to the end of the list, which is also the start of the list in this case. So it travels to this and it stops there, because that at the moment is the end of our list. So it stops on this, and now I have this variable I'm able to add to the reference, so I can see I want to connect this node to the next one by storing the address or the next value. So now let me go ahead and remove this, or let me actually leave it. So now I want to add one more value right here. Let's say my names dot append dairy, and let me actually make this a little bit more descriptive. So I would say right, not that actually, right. So what I want to do here is remove this print and put it here. Print trying to, I'm going to use an if string, right? So trying to append to list, trying to append, let's put the value. So let's say, right, so let's use, what's it called? Value, right? So trying to append value to list, and last item in list equals, right? So let's do this, and let's say current data, right? So now let's see how this behaves when I run this again. So when I do this now, you can see appending to start of the list, which is for the first value, appending to the end of the list, right? Now we are trying to append Jeremiah here to the end of the list. Now currently the last item is uploaded one, so which is this. Now on the second time we try to call append Adeyeri, right? We are appending to the list, we are appending Adeyeri to the list, and the last item at the moment is Jeremiah. So we are able to connect them together using that. And now we are able to like append items to our list. So now let's write another function, another method actually, to now print out all the items inside of our list. So let's do something. Let's say def display, right? So let's say def display, and now for this I want to just have self, and what I want to do here is traverse all the items in the list and print out every single one of them so we can see the contents of our linked list. Right, so first we want to check, right? It will be pointless to try to traverse the list if it's empty or if it's just blank. So we use a condition to check for that. So I would say if not self dot head, what I want to do is return, right? Now in the case that the list is not empty, what I want to do is create a new current variable and say current equals self dot head, right? And now I want to traverse to the end of the list to say while current. Now I'm not using current dot next here because I want to go all the way to the end. I don't want to stop at the last one, so I want to end at the null value, which is why I want to use the current here. So while current, I want it to print current dot data, and here I want to say current equals current dot next, right? So this continues, and at the end of the list we want to stop. So the reason why I'm using one more time, the reason why I'm using current here instead of the current dot next is because inside of this append, I'm trying to stop at the last one, so I can now use that last one, append something else to the value. Now right now inside of this list, inside of this loop, I want to traverse all the way to the end. I don't want to stop at the last one because I don't need it outside of this loop. So I want to travel all the way to the end and print basically everything in the list, not just the last one. So yeah, that's that. And now when I run, let me go ahead and get rid of some of the prints that we have here to declutter our console, and we run the application. Right, so now when I run this again, yeah, I need to call the display function. So my names dot display, and now when I run my code again, we have all of the items in our list displayed inside of our terminal. Right, so that works. Now let's go ahead and try to append to a particular index inside of our list. So let's say we want to append on the second item. So currently we have like 3 items. Let's say I want to append something before this, right? Let's write a method to achieve that. So I'll be calling the method define, should we call that add at index. So add at index, and so I'll be collecting some values here other than itself. So let's say I want to take the value that you want to add, right? And then I also want to take the index that the user wants to add the item at. So what we want to check here is first confirm that our list is not empty one more time. So let's say if not self.head, just basically return, right? No, I don't want this. So just return, or let's just add it right at the end. So if not self.head, let's just append right the list to the head of the what's it called. So let's do this. Let's say instead of like having two implements, and let's just call self.append value, right? So we're skipping the use of the index there. But now in the situation where our list is not empty, right, what we want to do, actually in some cases we might want to throw an error here because the value is not, the index is not existing, but then let's just do that for testing purposes. Right, so now that we have already added the item to our head, in the case that the list is empty, what I now want to do is now use the index of 0. So in the case where our index is 0, right, that means automatically the user knows the list is empty, or either list is empty or not. The user is trying to add what's it called, the node at the start of the list. So let's tackle that differently. So let's say if index equals 0. So the user in this case is trying to add the node at the start of the list, either whether there are items inside of the list or the list is empty. So regardless, we need to add the start, which is the end of the list. Right, so to do that, what we do is say, let's create a new node. Actually, let me remove this. Actually, we don't want this behavior. So let's say new node. Let's create a new node equals node and value. Right. So now what we want to do is set the next item on the node. So let's say new node next equals self.head. So what we are doing now is we are setting the next value of the new node to the head of the linked list, which means that we are now connecting this node to the current beginning of the linked list, which will mean that what we now want to do is set this current new node to the head of the linked list, and basically we are done. So let's go ahead and do that. So let's say self.head equals new node. Now, given that the next value of this new node is now pointing to the previous head, the linked list continues. So that's basically how simple that is. And now we can just say return, because now it's done. Right. This is a situation where we are at the head of the linked list, or we are trying to append to the end of the head of the linked list, which is the beginning. So trying in append to 0 index head of list. Right. So in the situation where we are not trying to append to the head of the list, what we want to do is traverse to the list, traverse to that index that the user wants inside of the list, and actually append to that particular index. So to do that again, I'll create a current variable. So let's say current equals self.head, and now we're also creating a current index in this case, and current index equals 0 for a start, right? So every time we traverse, we like go to the next value inside of our linked list, we're going to be appending, we're going to be incrementing this value by 1 to keep track of our current index inside of the traversal of the linked list. Right, so let's now do the while loop again. So let's say while current, but then also and current index less than index minus 1. Now, so what I'm doing here is I want to continue to iterate and traverse the linked list while I still have a current value. But then also I also need to check that our current index is still less than the index we're trying to append to. So we're trying to stop one step before the particular index that the user wants to add. So let's say you want to add to the index of 2, right? I want to stop on index of 1, so I can now append to 2. So that's basically how that works. Now let's say, actually let me just print, not here actually, let's say every time we traverse we want to say current.next, current equals actually current.next, right? But then we also want to increment the current index by 1. So let's say current index plus equals 1, right? Now at the end of this loop, we would be at the end. It's not the end actually. One step to the particular index that the user wants to add, except in a scenario where the index the user is trying to add is not existent, like it's longer than the entire list itself. In that case, our current value would be none. So what we want to do here is say if not current, then in this case it means that, let's say the list is 5 items long, which means the max index is 4. If the user provides an index of 7, that would mean that currently our current value will be a non-value because it's beyond the end of the list. So in this case, we just want to return, and before that we can actually print and say index out of range, right? Because yeah, now if the index is not out of range, that means we have successfully stopped one step before the index that the user wants to add or that we want to append to, right? So in that case, what we want to do is say new node the next, right, equals current the next, right? So what we are doing is our current node, right, we need to connect our current node to this node and this node to the next node, which the next node being the node that is next after the node we are currently on, not the new node. So now what we want to do is set the new node to the same reference that the existing current node has, and now connect the current node to this particular new node. So now the next thing to do here is say current the next equals new node, and it's basically as simple as that. So now we've been able to add at the index, right? In order to verify that this works, what we want to do here is add a print, right? So let's add a print and say, okay, let's say on f string one more time, trying to append, let's say the value, right, at index, right? But then we stopped at index of, say, current index item is current item actually. So current item is current.data. So let's see what this looks like, right? Let's also try to call this function. Let's say my mains.append. Let's say I want to append to the first value, which is the second, because I use the index of 1. The index is based in 0. So if I use the index of 0, I'm trying to append to first place. If I use the index of 1, second place. And let's see what happens now. So in this case, I want to now say append in the index of 2. No, add at index, and then I want to add test addition at index of 1, and then that's so dot add at index. So I want to append test addition to at index of 2. Right, so let's see what happens in this case. Now when I run my code, you can see trying to append test addition, which is this, at index of 1. We stopped at index of 0, and then the current item is Opeoluwa, which is this. So now we are trying to append in between Opeoluwa and Jeremiah. We stopped at Opeoluwa just so we can append in the middle of both of them, right? And then on the second case, we are seeing trying to append test addition 2 at index of 2. We stopped at index of 1. And then the current item is test addition, which is this. So basically that works. And now just a recap. To append, we traverse to the end. To append, to display, we just traverse all the way and print. Then to add at an index, we traverse and continue to traverse while our current value, our current index does not exceed the value that the user has provided, or the that the function was called with, method was called with.